Welcome to my Webber session today. I wanted to talk about CIM compliance. So CIM compliance, CIM being the Common Information Model, and CIM compliance as a definition is the process of normalizing your data. In this case, let's say, for example, making sure that X equals X no matter what, or rather X is a letter no matter what. 1 is a number no matter what. More real world example, let's say you go to the grocery store, you want to get cookies. If I said, hey, can I get some cookies? It doesn't matter if there's raisins in it, if there's chocolate chips, if it's an oatmeal cookie, if it's shortbread, it's a cookie regardless. So in terms of Splunk CIM compliance, that would be that the field cookie is extracted, and no matter what the value or type of cookie there is, it's still labeled as a cookie. And that's the normalization of it, that it's consistent across the board. A couple of ways we can achieve CIM compliance. You have through data models. You have search macros, and field extractions. And field extractions being, an alias or a calculated field. Starting off with a data model. So a data model being a hierarchy structure of data sets. So to be more specific, let's say if you're familiar with an authentication data model, or the idea of the authentication data model would be having your fields that are extracted, either recommended or required, fit the model of authentication. It's saying that based off of this model of what this data should be, this is what you would need to see from this data source. So you say you're getting logs from Windows. If you attach your Windows index to your authentication data model, it'll have some extracted fields like the action, the application, maybe outcome. There'll probably be an event code behind that. So normalizing authentication data in this sense would be attaching what a search macro is to your data model. So to get more in depth into that, what a search macro is a condensed search. If you're familiar with Splunk language, let's say you have index equals Windows, and you have index equals Linux, and you also have index equals AWS. You are trying to get your data normalized to authentication, and you have 3 different indexes, 3 different sources, and you probably have multiple source types from this. To be able to get this into a search that is optimized, what you would do is put that into a search macro that says, okay, for this search macro, CIM authentication indexes, you're only looking at this index, and this index. Let's say you specify source type. So source type, Win event log, source type, Linux audit, and then of course, AWS source type. You are telling Splunk to look into these indexes and these source types for the data that you're looking for and nothing else. This, in this sense, allows you to optimize what you're running on the data model. And then to get more in depth in data models, you can accelerate them to look past a year and more. But for just search value for a data visualization like a dashboard, alert, or report, search macros allow you to basically specifically look in somewhere. So look at a specific index, look at a specific source type to be able to extract any fields or any required fields from your data model.
Cool. Yeah, so I'm going to try to paraphrase a little bit and let me know if I'm wrong in any way, bro. So data models, so you're basically saying data models are like, let's say, we'll use like a random example. Let's say in this house, we have like a bunch of like black stools. So a data model would basically say, okay, in the house, whatever black stools there are, find those. Those are the types of like things I want. That's one kind of data set. I know it's pretty random.
Right.
But another example I think that might actually be even better, because I used it maybe a few weeks ago, was talking about like logins, authentication, since that's what she used. So let's say, for instance, somebody has like a laptop, right? So if their laptop, somebody logs into their laptop, that's an authentication.
Right.
Versus them logging into Facebook or logging into Instagram, that's still an authentication. So that data model will look at all authentication, regardless of like Instagram, Facebook, your laptop, or into like your, what do they call it, Blackboard for like, school. This is authentication. So does that kind of...
Yeah, so it unifies the word. So for example, to stool, stool is the field, and the value, no matter of the color of the stool, is still a stool. So making sure that in a production environment, that to the example of authentication, the action of authenticating, regardless of the result, is the same. And that helps look at things like metrics for your data. It looks at reports for, brute force attacks. You be able to say that the action of authenticating was failed this many times. That needs to be defined across the board, so that whether for a new person entering the environment or for someone leaving, that's the blueprint. That's the normalization is the blueprint for what should be in your data set.
Gotcha. And then for macros, I think using your example of index equals Windows, index equals Linux, or index equals AWS, you're just saying it's just like a shortcut.
Yeah.
Macro says it's just a shortcut.
Simply, yep.
Okay.
It basically says, hey, I could put index equals star, which you shouldn't do, or underscore star, but no, I don't want to look everywhere.
Yeah.
I just want to look right here. This is where my data is, and this is what needs to be extracted.
Yeah.
So ignore everything else, and now make my job easier, optimize this.
Okay. So we'll go off that example also with authentication. Let's say I want to look at only when people authenticate to Facebook, Instagram, or TikTok accounts. So then that would be index equals TikTok, index equals Instagram, index equals Facebook. And then my macro is going to be social media authentication. So that'd be like a macro.
Yep. And to add to that, you have tags involved with data models, where instead of the platform being the field, it can be the tag. So you tag all your data. This is Facebook data.
Yep.
We have it in an index called applications, and we want to tag Facebook data to look at authentication for Facebook. You, in your search macro, specify, okay, I'm looking at index equals Windows that has Facebook data, but with the many source types that can come from Windows, you say, I only care about the ones that say tag equals Facebook. And with that, if you say only have 3 events that are related to Facebook, the Splunk environment isn't going to look through a year's worth of data for 1 million events. It's going to now specify, okay, I only care about that which has the tag that I'm looking for.
Gotcha.
And that also helps, again, to use cases to where, as you're searching through it using the authentication data model, you have that data already specified. It helps with searching it, it helps with indexing it, and those field extractions, because you run a pipe data model search to look at that data model, you can see what you're extracting, and then it kind of helps with those use cases.
Makes sense. Okay, cool.
So we already talked a bit about the field extraction part, but to the normalization, to be able to say that a cookie is a cookie across the board, you need that field to exist. Mm-hmm. That starts with field extraction, whether a calculated field or an alias for that. So in some instances, you have your data already being extracted, and you have like Splunk add-ons, or maybe a field extraction you made on your own. Mm-hmm. Cookie. We already know, okay, we're looking for a cookie, and the value for the cookie would be an oatmeal cookie, raisin cookies, chocolate cookies, etc. Mm-hmm. But let's say this didn't exist. We're looking in our logs, and we see that, going to the grocery store, we have 15 customers that bought 15 different types of cookies. Mm-hmm. You see in the log, in their receipt, the purchase for each cookie, but you want to be able to make a visual for that metrics that says, okay, what type of cookies did people buy? What did they look for? So, a way to go about that is through the field extraction. So, a form of regex, if you're familiar with that, is just a regular expression which you're doing a character extraction from the logs. And how that would work is, in this case, you extract from the field, let's say the type of cookie. Example would be, you have like 2 lines of logs and they say the user's name, the purchase, successful purchase, card declined, that would be the action. And then, the receipt of what they purchased. So they bought fruits, they got vegetables, they got snacks, and in this case, a cookie. So you would do a field extraction that grabs, the type of cookie in this case and calls it cookie. Another way of that same field extraction is in case this field is extracted under the word snacks. According to the data model, let's say the food data model, it says that for this word snacks, or for your data to be normalized, the word snacks needs to be specified to what you're referring to. In this case, to normalize your data according to the food data model, cookie or snacks is a recommended or required field that needs to be cookie. And in your description, in this case, you would check on your Splunk docs and look that up, and it would say snacks is a recommended or required field, and a definition of snacks is a light meal or just something that you can nibble on. And in this case, now you look through your logs, what would be something light that you could nibble on, and then you see a snack or a cookie in this case. You create a field extraction for that, or an alias. So if the field snacks already exists and the value is a cookie, you can create an alias that tells Splunk, hey, every time you see snacks, I need you to call it cookie with the same values of what is under snacks. And what that does is now you've unified the word cookie. This field exists with exactly the different types of cookies. And that would allow you create a dashboard for this report. Okay, we have our user, we have the date and time, we have the action, and then, let's say the item. Now, the item field is cookie compared to snacks, which is more general overview of a snack. And last, of course, a calculated field, which can be an eval statement. So, for example, going back to our search macro, let's say hypothetical that in the Windows events, we have the purchase of a cookie, but in the log itself, we don't see any example of a cookie. We know that in this transaction, there was a cookie purchase, and we're trying to identify that. So one thing you can do is create a calculated field that says, anytime you see this index with, let's say not this, with a cookie tag, we'll go to tags, a cookie tag under the snacks source type, we call this field cookie. And what that does for us is we're creating a calculated field to be able to extract this cookie field and value. And that also helps us with the normalization. Example would be now if we see that in our data model. And this would be, this would be a way that you could extract fields, or at least to normalize it so that as you're searching through your data, it's consistent across the board.
Gotcha. So going back to your snacks example. So let's say, for instance, so if your snack, let's say you write oatmeal, I guess, next to snacks to the right there, oatmeal cookie. And then, so whenever you're saying, if there's let's say I did a search in let's say in Walmart. I was online on a Walmart store, and I did a search, and I did a search for oatmeal cookies. And when I did a search on Walmart, it has like these little tags on the left side. It says, hey, these are what we have under snacks. You're saying that from a Splunk perspective, regardless of whether it's called snacks in Walmart or whether it's called like, edibles in, some random grocery store, or called capital C for cookie or K for cookie, regardless of where it's at, you're going to say that that field is going to be called cookie with COOKIE capital
Exactly.
C.
It ignores everything else outside of what we define. That no matter where you go, what aisle you look under, this is a cookie and nothing else.
Yep. Okay, perfect. So for those who are trying to understand, so if you're trying to search a store, regardless of where it's inside of a store, or any stores in general, and you're trying to look for cookies, it'll tell you exactly where in the aisle you should look for. So imagine having a tool that can tell you in 3 billion stores across, the United States and South America combined, or, countries in South America combined. If you wanted to look at where every cookie is at in every store, Splunk can tell you that as long as you have the logs that can, tell you where in the aisle certain things are located and what those names are. So that's pretty cool, man. Okay, anything else?
No, I think that's it. I could, of course, dive a lot more into it, but for time, I think this is just a general overview of CIM compliance. It's something that I have to do consistently almost every day. So to a point of repetition, being able to understand this helps a lot, especially this goes across other tools outside of Splunk. Most tools, you have a framework, you have a model for your data and what it's supposed to look like. So I think this process of just CIM compliance is pretty universal across the board. So I think this is something that I think a lot of people will benefit from, getting the time to learn and at least be consistent with it. Because even if you're not hands-on working on CIM compliance, the process in which you are creating your visuals starts off with, do you have the fields you need to create that, and what do you need to get that done? It may not be a search macro and they may not all be together, but I think overall compliance is the talking point.
Cool. All right. So I'm just going to do a quick last overview. So data models you mentioned are ways for us, we'll keep with authentication since that's what you used. It's, let's say you logging into whatever thing you log into, Facebook, Instagram, whatever it is. Let's use social media as a base. Data models allow you to say, okay, these are just people logging in general, authenticating, right? And then macros just say, okay, regardless of like where they're logging in from, I still want to be able to look at that in a quick way where I don't need to look at like all my different sorts of like logs. I just want to see when people log in. So macros allow you to do that. And then your field extractions, aliases and calculated fields allows you to kind of say, okay, this is what a login looks like in Facebook. This is what a login looks like in Instagram. This is what a login looks like in TikTok. So on the back end, the actual logs may look differently, but you're saying make it normalized across the board.
Yes.
Dope, man. Okay, cool. Well, Adryan, thank you very much for insightful whiteboard session on CIM compliance. I think we're good here, man.
Hey, what up, fam? This is Sar Levy, host of Africans in Tech, where we're building bridges and shaping futures in tech. Just a quick reminder for those who've not yet subscribed to our YouTube channel, hit that subscribe button. You can catch all of our content, including our whiteboard sessions, where you'll find our full-length videos on our channel. And hit that notification bell, fam. All right?